Problem number 5. Figures 1, 2, 3, and 4 consist of 1, 5, 13, and 25 non-overlapping squares respectively. If the pattern were continued, how many non-overlapping squares would there be in figure 100? Oh boy. Well, I wouldn't recommend drawing these figures out up to 100. I would look at this and find a pattern. Now, you can look at the sequence of the number of squares, but you can see that it doesn't really help us too much. I mean, you can see that the difference here, we're adding 4, and then we're adding 8, and then to go here, what are we adding? 12. Okay. So you can see that it's not an arithmetic series, although you can see that that if you look at the differences between consecutive numbers, that difference is actually an arithmetic series. At least as far as we've drawn it out, it appears to be, right? And I think that's the key, is to look for something about these diagrams that give you an arithmetic series, because it's fairly easy to work with arithmetic series. So let's take a look at the dimensions of this. So we have, here it's 1 by 1, and here we have 3 by 3, right? So the width and the height are 3. Here the width and the height are 5, right? So we could write those out, 1 and 3 and 5, and then you can see that the width and the height here are 7. And you can see that is an arithmetic series. It's just the odd numbers, right? So in case you haven't seen my videos on arithmetic series, an arithmetic series is just a sequence of numbers where there's a common difference between consecutive numbers. Okay, so here you can see that the common difference here is 2, right? So to get the next number in the series, you just add 2 to it. Okay, so let's work with the width of this figure and see if we can figure out from the width. If we know the width of the 100th figure, then it wouldn't be too bad to figure out how many squares are in that figure. Because you can see, for example, in figure 4 here we have 7, and then we have 5, and then we have 3, and then we have 1. So this is an arithmetic series, and then also we have 5 and 3 and 1, and then so we have another arithmetic series down here. Okay, so if we can figure out the width, and if we know that each subsequent row above and below the longest row is just 2 less than the one above it, then we have a chance of getting an answer here. Alright, so let's look at the pattern of the widths and see if we can figure out what the width is of the 100th figure in this series. Okay, so our sequence looks like 1, 3, 5, 7, just all the odd numbers. So what's the 100th one going to look like? Well, essentially we take 1 and we add 2 n minus 1 times, okay? So for example, if we could use this formula to figure out any of it, any of the numbers, we can figure out the 4th one, because essentially to get the 4th number in the list, we've taken the first number and added 2 to it 3 times. Okay, so this is the expression for the nth term in this list, and we could actually rewrite that. If we distribute the 2, we can get 2n, and that's minus 2 plus 1, so it's be 2n minus 1. Alright, so the 100th term then would just be, if we substitute 100 in for n, we get 200 minus 1. So the 100th whoops, 100th. Yeah, that doesn't look very nice. Let me start again. So the 100th term is just equal to 200 minus 1, which is 199. All right. So now we know that the 100th figure in this sequence is 199 squares wide. Okay. And then the subsequent rows, let's take the rows above it. We'd have 199 in the middle row, and the row above it would have 197, and the next row up would be 195, and so on until we finally get to 1. Okay? And we had a tricky little way to add an arithmetic series, and if you haven't seen that, I recommend you take a look at my videos on arithmetic series under the lessons section. But because essentially if we call this S, and we write S again only in the reversed order, so we have 1 plus 2 plus 3 plus 199, then you can see if we were to add up those two, so we get 2S, that's going to be 200 plus 200 plus 200. Wait a minute, hold on. I'm getting crazy. Alright, so this isn't 2, is it? And this isn't 3, because we're just adding the odd numbers, right? So this has to be 3, and this has to be 5, alright? That's why you're probably thinking, oh my goodness, she doesn't know how to add, but it should be the odd numbers. Okay, so when we add those all up, we just have a string of 200s to add, and so we need to know then how many 200s do we have in this list. And if we add up, if we count all the numbers, all the odd numbers between 1 and 199, you'll find that we have 100 of them. Okay, so there's also a formula that is derived from this reasoning, but we take the first number, which is 199, plus the last number, which is 1, times the number of numbers, which is 100, and we divide it by 2. And if we do that, this is just 200, 200 divided by 2, so it's 100 times 100, which is just 10,000. Okay? Alright, so there'll be 10,000 squares above the middle width, above the longest one in the middle. So let's figure out, let's apply the same reasoning to find out how many squares are below the longest one in the middle. So we've already counted the longest one right here, the 199. So we can just add the numbers from 197 to 195. Oops, 195. And so 193 and so on all the way down to 1. Okay? And we can use our little formula, so we'd have the first number plus the last number, so that's 197 plus 1 times the number of numbers. Now, this is basically the same list that we had before up here, except it doesn't have the 199. So we have one less number. So we have 99 numbers in this list. We divide that by 2. So essentially we have 198 divided by 2. So let's see, what is that? That's 99, right? Is that right? Yeah. That 198 divided by 2. Yeah. And then, so if we multiply that out, we get 9801. Okay. And then we can just add these two, because these are the number of the number of squares from the longest width to up to the top, and then these are the ones from the one below the longest one down to the bottom. Alright, if we add those all up, we'll have the total number of squares, which is 19801. Alright? So, the answer is there's 19,801 squares in the 100th figure. And You'll be glad you didn't draw all of those out because that's a lot of squares to draw.